In this video, I will explain how the code you have entered into your Arduino works. The first line is just a comment that is written using 2 forward slashes. This means that it is not a part of the code. The next line introduces your micro servo into the code as an external library so that you can reference it later. The third line simply directs your code to myServo, which is the variable set for your micro servo, meaning that the code can be transferred. Remember that the semicolon at the end of each line symbolizes its ending. This next part of code is part of a void setup. This means that anything between the curly brackets will be run just once. The second line means that this code will work from where the micro servo is attached to the nano board, which allows the board to communicate to your micro servo via the pin that you insert. In this case, it is pin 9. It's important to know that digital pins have nothing in front of them, whereas analog pins have an A. This means that the pin is digital. This next line sets up an analog pin A0 as an input pin rather than an output. This means it will gather the information rather than carry out an action. The next line sets the rate of incoming data to 9600, which means a serial monitor can process a certain amount of values coming from the flex sensor. The next block of code is written within a void loop. This means that the code within the braces will run repeatedly once it is uploaded. All the code that will allow the servo to respond to the flex sensor must be here. The first line introduces the flex sensor and shows that it will be connected to the nano board via analog pin A0. This allows values to repeatedly be read from the flex sensor. Again, the pin will change depending on where you have connected the flex sensor to. The next line confirms the angle at which your micro servo will rotate. To calibrate your finger, look at the serial monitor and find the difference of the lowest and highest values. Then find a number to divide this by that is closest to equaling 180 degrees. The next line prints the angle to the serial monitor so that you can see the values coming from your flex sensor. Finally, this last line means that the value from the calibration is transferred to the micro servo so that it can rotate the amount of degrees that you have written, therefore bending your finger. Congratulations, you now understand the basics of coding a bionic finger. The finished product should look something like this.